Hey guys, Mr. Milton here. Today we're going to talk about solving equations. At the end of this video, you should be able to solve equations with variables on both sides of the equation, or the equal sign. And then you should be able to identify an equation with no solutions and infinitely many solutions and differentiate between the two of them. So in the last lesson, we learned how to solve an equation with variable on one side of the equal sign. What happens when there's a variable on both sides? First example here, we're given 7 minus 6x equals 5x plus 29. Noticing that there's variable on both sides. So I'm going to start by moving my variable to the other side, add 6x to both sides. Okay, and that gives me 7 equals 11x plus 29. From there, I'm going to subtract 11x from, subtract 29 from both sides. And that leaves me with negative 22 equals 11x. And then I'll divide by 11 on both sides to get x all the way by itself. We find then that x is negative 2. I'll write that over here. Okay. Give you a second to write that down as I erase this problem so it doesn't spill over to my answers. Notice how we're basically doing the same thing we did in the last lesson, except we aren't just moving the numbers, we're also moving variables. So here's the thing that you need to make sure that you remember. If you're moving a whole term, so for instance, we're moving negative 6x. You see how we did that? You add or subtract, right, depending on the sign in front of it. But if you're moving, if you're breaking up a term, let's say that example, when we did that with 11x, you notice how we broke up the 11 and the x. Use multiplication or division, depending on what's being taken away. If it's a fraction, we'd multiply it. If it's not, then we divide. All right. So let's go through some problems. Here we have 6x minus 5 equals x plus 15. As I start, I always want to make sure that I think about my variables first. And how I'll think about my variables here is I want to make sure that I keep my x positive. So I want to subtract the x from both sides. I end up with 5x minus 5 equals 15. From there, I'm going to add 5 to both sides. And I get 5x equals 20. And then divide by 5. And x is 4. Okay, so getting the variable in order first helps us to keep those steps down. Number 2, I'm going to distribute this 4 to both terms here. I'm going to distribute the 3 to both terms here. Okay, so when I do that, I'm left with 4x minus 24 equals 3x plus 3. Okay, and now I'm just going to go through and solve it, taking care of my variables first. So I'm subtracting 3x from both sides. And that gives me x minus 24 equals 3. And then add 24 to both sides. And I should find that x equals 27. And again, you can always go back, plug it in, and make sure that your answer works out. Number 3, we have a proportion, x minus 1 over 9 and x minus 4 over 6. Remember, proportions, we'll solve these by cross multiplying. My hint is to always put this in parentheses so you remember to multiply the whole group and not just the first number. And when you do that, you will get 6 times x minus 1 equals 9 times x minus 4. And so we get 6x minus 6 equals 9x minus 36. Caring for my x's first, so I'm going to subtract 6x first from both sides. I'll get negative 6 equals 3x minus 36. Add 36 to both sides. And we get 30 equals 3x. divide by 3, and we find that x equals 10. That is a 10. Okay, and now on the other side, so we got some multi-step happening, and we've already kind of done multi-step. Kind of goes with the territory when you're doing variables on both sides. Hopefully now you guys are getting really used to this process. So I distribute this -4, so I should have -4x minus 8 equals 5x plus 12. Now I will combine my like terms. 3x and -4x gives me -1x. I'm just going to say -x minus 8 equals 5x plus 12. So notice, just like we talked about last time, we want to really combine like terms before we move from the left to the right. So now I'm going to move to the right by adding x to both sides. And so I have -8 equals 6x plus 12. Remember that number in front of this x was a 1, right? Subtract 12 from both sides. Okay, and I should get -20 equals 6x, and then finish it off by dividing by 6. And that will give me x equals -20 over 6, which we could be done, but we wouldn't be correct all the way because we need to make sure that we simplify this fraction. Both of these can be divided by 2, right? And so x would be better written as -10 over 3. Everything Plumbing charges $46 for, okay. Everything Plumbing charges $46 for service call-in, in addition to $18.50 per hour for labor. Plumbing Experts has no charge for service calls, but $30 per hour of labor. Okay, what number of hours would both companies cost the same? So here we're looking at two things, and I always like to label my equations. We have everything plumbing, E, P, and PE, come on. All right, so everything plumbing starts with E, I'll use that, and then plumbing expert starts with a P, I'll use that, just to label it for myself a little bit. So when we're thinking about how much everything plumbing costs, we say, okay, well, it costs us $46 for a service call. So if I call them at all, it's gonna be $46. And then after that, I'm gonna give myself a little bit more space. So if I call them at all, it costs me $46. Then after that, it cost me $18.50 per hour. X or H per hour. Okay, for plumbing experts, it doesn't cost me anything to call them, but for every hour that they spend working, they charge me $30. Okay, so here I have a variable on each side. In order to solve, I will start by subtracting 1850 from both sides, 1850H, get my variables together. I'm gonna write this over here, even though I usually like to work down. Okay, but that will leave me with 46 equals 30 minus 1850, which is 1150H. Okay, and so using my calculator, in order to find out what H is, I need to divide both sides by 1150. Okay, and that will give me 4. So 4 hours. After 4 hours, it doesn't matter who I call, at 4 hours. Okay, so our equation, and this is the important part, we can't just skip to the answer, 46 plus 18.5 H equals 30 H. Okay, how much would it cost for that number of hours? Now they're asking us, okay, if it was 4 hours, how much would it cost? Well, we should just be able to plug that into one of the equations. I'm going to choose the second equation because it's just a little bit easier, because there's just one operation, 30 times 4. And so it would cost us $120. It took 4 hours of labor. That's when their prices are the same. The second question is more thinking about the equation and how it works out. It says, which company would you choose if you had a job that was going to take 6 hours? Well, we have to think about who's cheaper first. Okay, because if at some point they meet, then that company is not going to be cheaper later. Okay, so we could plug in 6 hours to both equations and see. Again, this 30H one's pretty easy. 30 times 6, and that's the plumbing experts. Plumbing experts would cost $180 at 6 hours. For everything plumbing, we have 46 plus 18.5 times 6. Okay, again, using my calculator, 18.5 times 6 gives me 111 plus 46, and that gives me 157. So I would choose everything plumbing at 6 hours because I get to save about $23. Special cases, let's look at special cases and see what they look like. So we have 2 times 3x minus 4 equals 6x plus 10. Let's go through and solve this. So as distributing the 2, we get 6x minus 8 equals 6x plus 10. So again, I start by getting my variables together. I'm going to subtract 6x from both sides. And when I do that, I end up having negative 8 equals 10. Okay, so what do we notice? The variables cancel or cancel out, however you want to say that. They're gone. They disappear. We say this equation has no solution then, since the remaining numbers are unequal. Right? Negative 8 does not equal 10. Negative 8 does not equal 10. That's no solution. Okay. So looking at the second problem, we have x plus 3 times x minus 2 equals 4x minus 6. So again, distributing that, distribute. So we have 3x minus 6, still x over here, equals 4x minus 6. Combine my like terms, I see that I have 4x minus 6 equals 4x minus 6. Now at this point, hopefully you see something, but we'll continue anyway. I'll get my variables on the same side and subtract 4x from both sides. And when I do that, I'm left with negative 6 equals negative 6. Okay, again, you should notice that the variables cancel out or disappear, however you want to think of that. We say this equation, though, has infinitely many solutions. Okay, since the remaining numbers are equal. And what that basically means is no matter what value we put in for x, this equation is going to work out. Okay, so no solution means no matter what we put in for x, it's not going to work. Infinitely many solutions means no matter what we put in, it is going to work. Circle the equations that have no solution, underline the equations that have infinitely many solutions. So 7x minus 1 and 7x plus 1. As we look at this, we should see at the beginning, really, subtracting 7x, we end up with negative 1 equals 1. Well, negative 1 doesn't equal 1. This is no solution. Here, we subtract 3x from both sides. We end up with 7x plus 7 equals 7. And then we would subtract 7 from both sides, and we get 7x equals 0. A lot of people, especially first learning this, will say, well, there's no solution. No, remember that no solution happens when our variables are cancel out. When our variables get canceled out, that's when it's no solution. Here we still have our variables. Divide by 7 on each side, we find that x is 0. Definitely has a solution. C, as we distribute, seeing what's happening, we have 4x minus 6 equals 4x minus 24. Hopefully you see it at this point, but I'll take it one more step just in case. Subtract 4x from both sides, and I get negative 6 equals negative 24. That's not the same. Okay, so there's no solution here. And D, as I combine my like terms, I have 5x plus 4 equals 5x plus 4. Okay, subtract 5x from both sides. Hopefully you see it now, but maybe you didn't. We get 4 equals 4, which means infinitely many solutions. Why is B not a special case? Again, the x's never cancel, the variables never cancel out. So we're good. If the variables don't cancel out, that means there is a solution somewhere. All right. So those are the notes for solving equations with variables on both sides. Yeah, see ya.